Welcome back to linear algebra. I'm gonna jump into Anki now. Okay. Well, must the product of upper triangular matrix be an upper triangular matrix? The product of two upper triangular matrices. Yes. If a linear system has infinitely many solutions, what is the general solution of that system? It's basically a set of parametric equations that, when the variables are plugged in for, can solve for or can give all solutions to the this linear system. Set of parametric equations from which all solutions can be obtained by assigning numerical values to the parameters. I think it's good enough. What must be true for the product of two symmetric matrices to be symmetric? They commute. Must the inverse of an invertible triangular matrix be triangular? Yes. Let A and B be square matrices. State two equations, either of whose validity guarantees that B equals the inverse of A. B times A equals I, A times B equals I. If A is a symmetric matrix, what is the relationship between A sub ij and A sub ji? They're equal. Must the product of lower triangular matrices be lower triangular? Yes. Cool. So on that note, I'm going to grade what I did yesterday, then I'll be back to recall how I did in a few minutes. All right, I got both problems from yesterday correct, so I'm going to keep doing more practice problems now. I'll talk to you in a little bit. All right, so I went back into the review problem from 1.2, and it was basically, I augmented this, but this was a huge set of linear system, I should say. 4 unknowns, all equals zero, so 0 is a homogeneous linear system. So I basically did Gauss-Jordan elimination up until I couldn't anymore. Then I pulled these two equations back out of this augmented matrix. And then I kind of just made up my parametric equations. I believe this works. It might not be exactly what the textbook outputs, but I believe this works as a set of parametric equations. Essentially, I substituted S for U and R for W and T for X and Q for V, and then basically just restated these equations with those substituted values and made sure that I said what the parameters are equal to. And then from today, from 1.8, I was given a basically set of linear equations, a linear system, told to find the standard matrix. So I basically put it into matrix form, or matrix equation, I should say, and then that just gives you the standard matrix, I believe, and then it's telling me to basically solve for this transformation by plugging these into the original equations. They're not written here, and then also in this system, and then multiplying by that standard matrix. So we'll see if we get the same answer tomorrow, which we should. But that's it for today. Talk to you tomorrow. See ya.